Okay, so I guess we'll get started. So usually Eric does this, but he's not here, so I'll talk. Welcome everybody to our FME and transportation meeting. And just as a reminder, we are always looking for input on improvements that we can make, and we're always looking for topics and new presenters and stuff. And so if you or anybody you know is looking to present, please let me or Jenny or Bo know, and we will add you to the list of upcoming presenters. So this is just a real brief agenda. We'll go over our group background and purpose. We do not have any polls, so I need to remove that from this slide. I'll introduce our speakers. Our speakers will give their presentation, and then we'll chat for a while and then have a brief wrap up. So FME and Transportation is a special interest group with the purpose of curating and sharing success stories, as well as best practices in applying safe software's feature manipulation engine, or FME, to the transportation sector. The creation of this special interest group was coordinated with the assistance of safe software and is meant to be vendor neutral. This special interest group was created with the hopes of unifying local governments, state-level DOTs, and the private industry, as well as serving as a holistic framework in which knowledge will be openly and actively shared via monthly presentations from community members and industry experts. These presentations will demonstrate and elaborate on real-world applications and success stories. Outside of the presentations, we hope this LinkedIn group will serve as a central repository for questions and answers as they relate to FME in the transportation sector. And speaker introductions. I just realized I didn't introduce myself. My name is Carol Francis, and I am a GIS project manager at Gistic Research. We also have Bo Glow, who is president and CEO of Gistic Research, and our co-host is Jenny. And Jenny, I am going to butcher the pronunciation of your last name, so please introduce yourself.
I'm Jenny Petrurio, and I'm a GIS analyst at Connecticut DOT.
Thank you. So our presenters today are Ethan Pointer and Erin Westfall. They are both at the Ohio Department of Transportation. Ethan has been working as a GIS database administrator in the road inventory group at the Ohio DOT for 4 years. His favorite FME transformer is a tester. Erin has worked with GIS in one capacity or another since 2002 in various industries. She has been a GIS database administrator in the road inventory group and HPMS at the Ohio DOT for 4 years. Her favorite FME transformer is a feature joiner. Erin and Ethan are here today to talk about road inventory data validations Ohio DOT performs using FME. And with that, I will stop sharing my screen and let you guys take over.
Thanks, Carol. And thanks, Bo, I met Bo at GIST, and we were in the HPMS workshop together and got to talking about FME a bit. And he said, hey, you should give a presentation about what you're doing at Ohio for our group. So thanks for the invitation. I also want to mention we have a third member of our team who's going to also be hopefully jumping in here today as well, Tom Acree, and he's really the FME power user here at Ohio DOT. So hopefully he can jump in and talk a little bit about what we do as well. So I think, Ethan, were you going to share your screen?
Yeah, I should have it up right now. Oh, well, I should push the share button.
Okay, so just a little bit of background on what we're going to talk about here today. If we want to go to our next slide, Ethan, can start. Okay, so just a little bit of background on some of our data validations. As Carol mentioned, we work in the road inventory team, so we're responsible for collecting all sorts of attributes about our road network. So pre-Esri, we used a system where we would use Access and GeoMedia to code our roadway data, and we would run nightly validations that would cross-check data that was stored in event tables. So that was way back in the day. In 2014, we switched to using Roads and Highways to manage our road inventory data. And the vendor who helped us get set up with Roads and Highways also created a custom validation application that worked online. And that worked pretty well. We kind of outgrew that though and needed to add some new validations and change some of our validations. And so we started doing that with Data Reviewer. However, in 2020, we made the switch to using FME, and we'll talk a little bit about maybe some of the why and the benefits to doing that. So next slide. So we found that compared to Data Reviewer, there was a greater processing speed using FME, and that was a big bonus, of course. Another benefit to integrating FME was that it replaced and consolidated some of our outdated validations. So we still, what was this, about 2 years ago, Ethan? We had still validations run with mainframe. And every year it would spit out these PDF reports that looked like hieroglyphs. And you would have to try to use a key to kind of interpret where the errors were with the event data and go and fix them. And it was a very lengthy, tedious process. And so FME helped us replace those. And another advantage to using FME is that we've found we were able to integrate some of the HPMS validations from the HPMS software. I don't know how many of you are familiar with HPMS, but every year all the state DOTs are required to make a submission of a great quantity of data to the Federal Highway Administration. And so certain validations need to be run on those data sets. And we were able to use FME to integrate those validations into our daily validations, which led to a much easier submission.
Hi, this is Ethan. I'll take over from now. So one of our hopes about using FME, currently at Ohio DOT, we publish our road inventory data once a year, but we're hoping now that by using the validations and having cleaner, or by using FME for our validations and having cleaner data, we'll be able to publish our data more frequently, as we know the kind of current state of how clean our data is. That we're hoping to start doing this in the next couple of years. So it's one of our long-term goals here. We also use FME server here, and if you're not familiar with it, I don't know the level of expertise here in the room, but it allows us to basically run all our workflows and validations on a schedule, and send out emails or links when everything's completed. It's a pretty simple application there. Another point about the FME server is it allows us, you can make kind of FME web apps. And so while we have this validations, which we'll be going over later, running nightly, I also created a web app which allows a user to run it on demand for a specific county or routes, or whatever, several counties if they want. And then it allows them to see exactly if they've just created any errors or if they fixed the errors they're working on. This has turned out to be a really helpful thing, and we have their users using it about every day. And then, so I'll go over kind of our workflow right now, what it looks like, kind of the overview, what things we're checking, and then I'll zoom in on a specific check, and then the output of what the users will see. So I am only speaking about our attribute validations. We do use FME to do some other spatial checks and geometric checks, which I believe Tom Acree will be speaking about later. So I am just going over our attribute checks. We have 350 of them, 351 of them, excuse me. And they run nightly, and they check all the event layers to make sure things are coded correctly. They check other things like, are some events null? Are they overlapping each other? Do we have duplicate events? Do we have multi-part line strings? But the bulk of the checks is just, are things coded correctly? So, just some random example, and I'm just making this up. If you have an interstate, the speed limit, cannot be less than, I don't know, 55 or something like that. So if someone has coded the interstate as 25, that'll kick out daily. And then the next day they can go and check and say, oh, whoops, I chose the wrong number. So just kind of a overview here. All our data on half the checks, it comes from what we here call the mashup table, where basically in a nightly process, we take all our event layers. I think we have 30, 31 or 32 of them. And we basically overlay them on top of each other and create this, very large mashup table, which has every route segmented. Whenever there's a attribute change, it creates a segment and then continues on through has the whole state. So I'd say half of the validations are run off of that mashup table. Allows us to cross-check multiple attributes at one time, say speed limit and street name, something like that. Rather than if you're doing an individual layer, you can only check, that layer without doing some joining and whatnot. So the way it works is basically we read in that mashup table and then they go into, hundreds of transformers. So they check all our event layers for different things. Erin mentioned in the past, we had a vendor create a web app for us for checking validations. But the problem with that program was we were not able to add any new ones. So that was why we switched out. And this allows us to, add a new validation, within a couple minutes, really, just a couple clicks, add in a couple testers and, write out the output and then throw it into the stream here. So I'll zoom in on one of these here. I've pulled it out already. Functional class. So the way it works is basically the data would come in, through the tunnel here and run into a tester. That's why I say it's my favorite transformer, because I have so many of them. And, it simply, we just have a couple of requirements, like, okay, so I'm saying, is the functional class not in these values? It cross-checks it against another one of our attributes. Okay, well, if it's not 9, it's not in these, and it's this, it will kick out as an error. Similarly, here's another one, the interstate. So is it an interstate, and is it not functional class 1? They're always 1. So if it passes, in this case, I have them set up. So a pass means it's failed the check. It's passed the error. So all the errors run into an attribute manager. And then here, all I'm doing is I give it a category, a code, an error message. Now we've tried to make these error messages as well written as possible, as condensed, but still allows the user to know exactly what they have to fix, so they don't have to go maybe check our manual or go ask someone else. In addition, I've included a query here. While these are not really SQL queries, they can't really be used anywhere. Most of our users are familiar with at least basic form of SQL or a query, as in you would see an arc map, and it helps them to identify an error if the message is not clear enough. So it writes out those error message and categories, sends it off into the writers where we, sort them out, and then they're all written out into a feature writer to an Excel sheet, which sorts it by the categories or errors. And this output looks like this. So this is an example of our daily output. So this is an older one, but you can see at this day we had 5 different tabs here. We had a lot of records with null values. We had some overlapping, duplicated events, but to specifically look at that functional class 1 we were just looking at. So you could go to the category, filter the functional class, and then here it is. Here's that one we were looking at. Interstate must be functional class 1. I've just highlighted it here, but we can see it was actually null. It didn't have a value. So then the users know, okay, from this begin measure to this end measure, I've got an issue. And the way we work here at ODOT is our users have assigned districts, you know, and counties within those districts. So usually the way someone will work is they'll come here and they'll say, okay, you know, I'm working in well, it's in this case, it was only Franklin. So I'm working in Franklin, you know, this is my district, and they just go straight to work fixing these errors. And same with all the tabs. And when there's nothing, there's no file output every day, but we typically have one. So that's the kind of quick overview of how we're checking all the attributes. So the other checks we have are some spatial or geometric checks. And Tom, Acree, do you want to speak on any of those? An overview of them?
Yeah, I can. Am I coming through okay?
Yes.
Yes, you sound good.
Okay. Okay. I don't have the actual workflows with me to share because I was having some issues with my laptop today, but I can kind of talk through it. So as I think Erin mentioned or Ethan mentioned, we use roads and highways. And what we wanted, we had some problems with the initial roads and highways installation, where during the compress phase of our rec and post, we were getting data would be fine in the QA version. And then once it got compressed into the default version, we would get a lot of geometric errors introduced by Esri itself. And we started realizing that there were data integrity issues with the overall Esri model. Like Esri will allow you to corrupt that model. I don't know how familiar you guys are with roads and highways, but suffice it to say that one of the validations that we do is we verify as part of that mashup generation, we verify before we generate that mashup, the integrity of the roads and highways data model. So we do things like guarantee that the centerline sequence is always tied to a valid route. It's always tied to valid calibration points. It's always tied to a valid centerline. That's one part of it. So we have one report that just verifies that that integrity is always good. Once we have that assurance, then we go ahead and we generate that mashup table. And the mashup table does a couple of things as part of that generation. It's actually an automation that's broken down into like 8 or 9 steps. And one of the first steps that it does is we recompute our state traversals every night. So we have a linear referencing system that's broken by county. I take that and using the topology tools built into FME, and I build that topology for our overall state network. So we build that every night and we verify that our state network is as we expect. We also have this concept of what we call leave reenters. Leave reenters are just gaps in the line work. If you're using a tool like roads and highways, you'll know that if I were to have like a clover leaf or something like that, where a road circles around on itself, you have to introduce like an alpha route. So where we have to create a tiny gap where this line string is crossing itself, or it wouldn't be OGC compliant. So we verify that the measures are as expected across all of those, and that we can hook all the routes together, you know, as expected there as well. So that's kind of an example of some of the geometry checks we do. Roads and highways, when it builds your network, it builds them into composite multi-line strings, I should say. So we verify that all the multi-line strings are consistent. Every single geometry has measures and that kind of thing. There's also error codes that Esri puts on the data itself. That's already exposed to the users, but we account for that kind of thing as well. So that's an example of like some of the geometry checks that we do. We had problems where we called them zingers when we were working with Esri. We make sure that all of the geometries are also like always guaranteed to be within expected boundaries and stuff like that as well. It just happened like a few days ago. I don't know how the user managed it, but somehow one of our roads ended up in Alaska somewhere on the center line, even though our network geometry was correct. So, you know, that gets caught because we know, hey, it's outside of our spatial boundary and that kind of thing as well. Any questions on that? Something that you may wonder, you know, because there was at the beginning, we talked about like, okay, we were using data reviewer, why would we switch to FME? And this was a decision that me and another user had talked about a couple years ago when we were looking at data reviewer. You know, Ethan talked about that mashup table and the fact that we have over 30 different event tables. And the reason we kind of went that route is because it was slow and clunky and very difficult to customize the output when you have interdependencies of the data between multiple event layers. So, you know, being able to, you know, make that happen with our mashup and then being able to customize the outputs and be very specific the way that Ethan has it in the current validations was part of the reason, and the fact that it was so much faster. Ethan, I don't know how much time your validations run, but I think it's definitely in less than an hour, where if we tried to do all these overlays and validations with data reviewer, it was just orders of magnitude slower to try and get something like these 300 and some validations in. Okay.
Yeah. Actually, one part Tom was just talking about our data viewer. We had one of the checks, I think using data viewer while I was working, for example, to just check for null records took 15 to 20 minutes. But within FME, it was less than 5 minutes. So that was actually my very first check. And that's why I went down the path of putting it all. One of the reasons, you know, we went from data reviewer to FME. But I think that's about all we had to share. You know, we're open to any questions there might be.
I have a question.
Yeah, sure.
I think this is a really excellent application. And in ADA and some other DOTs, I think FME, the first FME being used mostly in this LRS quality checks. And actually, I have quite a few questions, but I'm going to ask one. Hopefully that others will have more questions coming. And in general, I'd like to know, the mashup concept is wonderful, and essentially you denormalize it. Then you can essentially just query this mashup table to find all inconsistencies either within a particular layer or across different layers, such as you do the cross-layer check. I think it's beautiful design and wonderful. And how, since you have 32 layers combined into this mashup table, how long does it take? And how often you update these layers?
Yeah, I can field that one. So that is that nightly process that we talked about for building the mashup. And it takes, I think, 2 hours total, and we run it nightly, and we run it against our QA version.
Excellent, thank you.
And that's 30 some event layers plus. So the trick when we build that mashup is we don't use geometry for the overlay. You may know this trick if you're an FME user, but what you can do is you can instead substitute out the measures for the geometry. And that'll get you a very precise and much faster overlay when you're computing it versus the geometric overlay. So after we do line-on-line overlays with all of those layers using measures, and then we group by the route ID, then after the fact, I've got some custom transformers that actually take our county network and it slices it appropriately to reapply the geometry back onto that mashup output so that our data is published with the geometry from our geometric source of truth, which is our county network in roads and highways. Does that make sense?
Yes, absolutely. If think about if using geometry, one geometry would have many vertices.
Exactly.
So
this breaks it down to
that,
2.
Think about how much, how lean you are to.
Yeah, that's why we did it.
Become a number crunching, rather than a geometric spatial drawing and what have you. It makes things so much faster. Yeah.
We actually build custom transformers to automate a lot of that because we do it so much. There's also a lot of times where somebody will just come to me with pavement data, and all they have is the route identifier, the begin measure and the end measure, and no geometry, and then they want an overlay. And one of the questions that I always ask in the training, like, okay, Esri users, how would you do this overlay? And they're like, well, the first thing I need is the geometry, because I can't do the overlay without the geometry. And I'm like, well, we kind of automated this whole thing so that you can just pump in the measures and the route identifier and then the data that you want to overlay with, and it can do the entire overlay if your measures are good and your route identifiers are good without all of that geometric comparison. Like you said, it's very lean because it's only 2 points per segment.
Yeah, and I would like to echo you on that further a little bit. There's one other issues when Esri using geometry overlay. Not only the performance is bad, but in terms of data authority perspective is also bad, because ultimately for people, what's more authoritative? It is the from measure to measure, the original source. The geometry is one representation, but we know very well in Esri's environment, from measure to measure is not a true representation of the geometry. Geometry is not true representation of from measure to measure, which is supposed to be the source. And then you're using a secondary source to do overlay, not only slow as we mentioned, but also is unauthoritative. Think about that. That's another issues I think FME is allowing us to do beyond the limitations for Esri.
Yeah, and just to kind of add to that too, we have historical data prior to 2007. So we have geometry on all of our data, and we have all of our historical data built into consistent mashup structure back to 2007. But we actually did the effort of collecting all of the data that we could for our road inventory prior to 2007, all the way back to 1985. And we want to be able to build those same mashups, if you will. We want to be able to do that same overlay. And that's another place where, even though we don't have the geometry in an easy place to get to from back then, we can still do the data processing and the data analysis for like pavement data mashed up with or overlaid with road inventory data, for example. So it's powerful from that perspective. Sometimes you just want to look at the data and you don't really care about the geometry,
Right. Absolutely. Yeah. I see fundamentally LRS is in the domain of traditional non-spatial database domain, but it happens to cross the domain because people like to see the geometry as visualization or as a representation, but not the other way around. So it's fundamentally a non-spatial database kind of operation. That's my personal view.
Yeah. Yeah, I think it kind of goes both ways, and a lot of things that we also find, though, is we like people to be able to take our LRS with the measures mixed in so that when they go out and do field work, we get much more accurate measures. But when you got to start rolling up reports and doing things like that, it's really, the measures that get you the data that you want so that you can build the visualization with the geometry. So yeah, it's a interesting perspective. Any other questions out there?
Well, if not, let me fill in another question.
I have one question, Tom. So I do what you're talking about. I do a whole lot of manipulation where I completely ignore the geometry. That's one of the very first things I do when I read data into FME is I drop the geometry and then I just start doing manipulations with the table data. So I have it from measure to measure. And I'm just wondering if you have custom transformers that you have shared on the hub, because if you do, I would love to take a look at them and play with them.
No, I don't put them out on the hub.
Sure.
And I have probably, I don't know, 12 or 14. Some of them are tied specifically to ODOT, but lately I've been kind of going back through and I've been making them more generic so that, like, for example, something that comes up a lot we have our published annual road inventory. And I built a custom transformer that basically would say, okay, if you pass me in the route ID, begin measure, end measure, and you just want to apply geometry to it, it would hook right into that table and it would do all the work of dicing the geometry and dine-segging it to put the geometry on it. And then I recently went back and I refactored it because there are times where, hey, I just got some geometry from a source that's got measures on it and the same common route identifier, just make that my input and be able to run it through this custom transformer to apply that geometry to some tabular data. And I thought, that one, like that one for sure would be, something that somebody might want if they're doing linear referencing. So there's some approval that, probably has to go through before I start publishing, work out on,
Right. Yeah. I
just
figured
from a government perspective. We've
Mhm.
talked in the past about like, hey, we should collaborate with other states on open source. I'm a software developer by trade, so
Mhm.
I like write some of the some of our services and things like that, and I have like extensions to Java Topology Suite that I've written, and I like Java Topology Suite a lot if you are familiar with that project. But it's been it's been a little bit of a challenge, but yeah, like we have we probably have at least like 8 to 10 custom transformers that are fairly generic enough that anyone could use them. Might be, something maybe we present on in the future or something, and then see if anyone's got any real interest in them.
I would be very interested, Tom. Maybe in the near future, you can do something on how you share your generic custom transformers. Yeah. Pretty cool.
Yeah, I mean, I don't see why we wouldn't just give them away out on the FME hub, but I would have to talk to management about just making sure, just from the legal perspective, right? Like everything's got to. I think there's a certain licensing agreement to be out on FME hub that you have to meet. Like, don't you have to use like the Apache agreement or something like that? I'm not sure.
Well, we've been sharing a bunch of LRS. If you see any of the LRS underscore something, that's what Justic been posting. We have maybe over 20, maybe close to 30 custom transformers over there, up there. And most recent, some of the updates was actually in courtesy of Arizona DOT, because we are doing the consulting work for Arizona DOT, essentially updating them and posting them. We've been doing that for a number of years.
Yeah, I've seen some of them. Yep.
Yeah.
Cool.
Yeah, I just shared the link in case anybody would like to poke around and see what we have up there. Oh, there are 22 on the hub
22,
for your
okay.
reference. Yeah.
Yeah.
Yeah, we use the hub for a number of different things. Like I use their measure interpolator. I think that's actually maintained by FME, but it's considered custom. Like it's not part of the main package, and we have like a number of those transformers there.
Yeah. And I have one. Yeah, I will try one question here. So talking about alpha route, and I'm aware of your the way you guys handle that. I think a few years back, I was given your data set and working with Dave Blackstone, testing a few things. So it's not OGC compliant, as Ethan mentioned. So nowadays, I think Esri supports alpha route. And are you guys changing to using the Esri alpha route, or you would stick with the OGC compliance, where you keep a minor gap and perhaps changing the minor kind of measurement to ensure monotonicity across the same route? Is that how you guys doing it still?
Well, we have not upgraded to the new version of Roads and Highways.
Okay.
So we're still stuck with, ArcMap 10.7 something. So we have to continue to use the older version of Roads and Highways. But to speak to the new version of Roads and Highways, which I am working with another, a local that's currently installing Roads and Highways, the current version. Yes, you're correct. They fix it. All of the structure in Roads and Highways is exactly the same data model. The concession that they made is that they're writing the geometries illegally, like you say, right? Like they'll allow it to cross itself, and they just go ahead and serialize it that way. But if you were to run the database checks to validate the geometry, that would it would
Still
get a
fail.
failure there.
Right.
So I would think from a network perspective, we would want to fill in those alpha routes because we hate them. And I actually wrote, I already have a workflow that'll actually fill those gaps back in because they're very tiny gaps. They're only like not even a meter. Yeah, I think maybe it's like a half a meter each side by convention or something like that. So like when I build a topology at night, I actually go ahead and I fill those gaps in. But yeah, I think that we would probably want that, to have that filled in. And then when we produce our attribute data, though, we would, so like if I take the county network, when we go to publish it, we actually break it down into simple line strings. So I deaggregate all of the multi-line strings and so on like that. And if we had any lines that crossed on itself, we would probably just stick a break in, to make that geometry legal, just because I wouldn't want to, let's say that the feds want our LRS as just, an LRS file geodatabase or something. I wouldn't want to hand off anything that wouldn't pass basic OGC compliancy to them.
Yeah.
They would probably complain about it. So you just, probably, find those geometries that cross themselves and just break it right at the cross, and then it'll be fine.
I would agree. I think sticking with the OGC compliant is a wise policy. Kind of delete the common denominators that the standard we can all support.
The reason that Esri does the reason that Esri builds these non-compliant geometries is because the network model in Roads and Highways is it's built to fail because they have to have one record per route. So because they have to have one record, they have to aggregate all of the geometries together, and that creates the illegal geometry. If they simply deaggregated their network table, then they wouldn't have to create these illegal geometries. But apparently they decided that it was better to create bad geometry and not break their data model than it was to fix their data model. So that's kind of where they ended up at, because we had a meeting with them at one point and talked to them about it. And I asked them, I'm like, oh, so you're going to fix the network table so that it can have multiple records per single route? And they're like, no. Instead, they're going to write those geometries. But I did test it. I have tested it already with the new version of Roads and Highways, and it does work. It will allow you to create continuous geometries that cross themselves.
Yeah.
So,
Well, if there's no other question, I'm going to ask another question.
Please do, Bo.
Okay, and with the broken alpha route, so it's potentially causing monotonicity error. Do you essentially in the gap between the end of one line and start of another line, even however short they are, do you arbitrarily assigning different values, ending and starting value being different?
No, actually, we use the same measure so that the math on the line work will continue to work. So if I have a gap, it'll end at 1 and it'll start at 1. And what that does do is it creates ambiguity for the measure, right? Because now your measure is not unique on your line.
Mhm.
So we have a separate table that we call leave reenter, and the endpoint of that measure
Okay.
becomes the leave and the other one becomes the reenter. That's just a respected unique identifier.
Mhm.
And then for any of the geometric let's say someone gives me a bridge, and I'm running a process and I want to know, on which point that bridge is, if it happens to fall on that endpoint, they would get back both, or they can specify this is a leave or a reenter to call
Okay.
out which one the correct one is. It is a little bit awkward, and I work with other groups who have said, well, we're just going to throw a thousandth of a mile onto
Yeah.
the endpoint, but no matter what, it's really awkward. Like alpha routes that's why we want to get rid of them, because we would like to not have that ambiguity as much as possible.
Mhm.
It's an ambiguous point that really shouldn't have to happen.
Okay. Okay.
Yeah.
And speaking of monotonicity, do you have a mechanism to check your route's monotonicity violation in addition to using Esri's own tool? Have you ever tried using FME to do monotonicity check?
Good question, Bob.
We guarantee that the segments themselves are monotone. So they go low to high. That's part of that mashup generation, like some of the validations that we do at night. And we also guarantee that the calibration points are monotone.
Mhm.
But we don't generally, as a nightly validation, guarantee that the vertices themselves are monotone. And it's a question of, are we talking monotone or strict monotone, where every single measure must be increasing based on the size of the mantissa, like of the decimal places of the, because Esri carries it out to a really long decimal place. Like I have seen in our data where, some locals have digitized roads and they've put the vertices even on a straight line, like really close together, where they wouldn't be strict monotone. But we allow for that. But we do just validate that all of the measures, on the overall length of a single segment are monotone.
Okay.
If you want to do it on like every single vertex, you can, but it's a big network. And usually we trust that if the calibration points are monotone as they go across the center lines, as long as interpolation is working correctly, internally, that, we can trust that everything internally is monotone.
That makes sense. And in Arizona, we found because we do geocoding, sometimes it does not end. The closest vertices maybe null, maybe actually in the decreasing direction, even though it should be in the increasing direction. So we end up just saying, hey, let's just identify all those vertices being, in fact, we have like 3 or 4 different manifestations of non-monotonicity errors, and we end up identifying those for them to fix. Yeah, so all depends on the application. It might be worthwhile to look at that, because the outcome, not just on the map, on the route itself, but because we use the route to generate geometry for events. So the event might be different. And that also explained why sometimes the geometry generated in Esri would be in contradiction, or the length of geometry would be different from the length of from 2 measurements,
That would be based on your calibration points, because your calibration points can be a different measure from the 2-dimensional measures of the geometry.
Okay, yeah.
So for example, I could have something in 2 dimensions that's 10 miles long, but I can have my calibration points go from 0 to 9. And so Esri will just take, from one calibration point to the next, and it's going to evenly balance those measures across the interpolated geometry. FME does the same. Like if you use the measure interpolator, you can set the begin and end measure and then say, okay, interpolate what the measures are, and it'll just use % offset to calculate the measure. The reason I think for that, and what the reason why we would do it, is because if you're not accounting for elevation, right, you could have like 2-dimensionally when you're looking down on it, it could be 9 miles, but 3-dimensional if you drove down and up that, you know, hill or mountain or whatever, it could be maybe another 1/10 of a mile longer.
But typically in Arizona, DOT's experience and their from measure to measure would, because our from measure to measure is all supposed to be jive with the
Geometry.
distance of the geometry. Yeah.
Uh-huh.
And certainly if it's using DMI measurements, getting from geometries is different, but generally speaking, our case would be, but yeah, I see that point. I think that's all I have here. Yeah. Thanks.
No more questions, Bo?
No more. No more. I think that's just excellent presentation. And
I have a question. So is Arizona on the new version of Roads and Highways now?
They're on 10.8, I believe.
I
Okay.
think 10.7 at perhaps 10.8 or 10.7. We're looking to moving to Pro.
Uh-huh.
So how about you have any plans to moving to Pro anytime soon?
Yeah, that's what I think we're going to be looking at in the next month. We're going to stand up possibly a version of Pro. At least we're going to discuss it. Like I said, with another group that I'm working with, they are using Pro. And, you know, Pro is going to change a lot in your life if you're used to 10.7, because direct database access and version views are going to go away for you. And you're going to have to use feature services, and you're not going to be able to query database tables directly. So it's just a heads up.
Yeah, I was wondering if FME has the Pro's version, the new
Branch versioning.
Yeah, branch versioning supported interface or not. Yeah,
It does. So
Yes,
there's a portal reader and writer that
Mhm.
will allow you to read from the feature service, just like you're reading from the database. So as long as you don't want anything more than to read the data, and you can give it SQL criteria against a version, it can read that branch version. There's no branch hierarchy anymore. Like there's only one level. So you would have default, and then whatever your version is. There's no
Right.
reconciliation like QA. And currently, like, you have all your add delete tables.
Mhm.
Those add delete tables go away.
Okay, right.
And all of your redo undo stuff gets written directly into the base table. So
Yeah.
trying to make sense of, I actually deconstructed branch versioning and the SQL involved to try and create something like a version view. And it's like very, very ugly. It's like 3 subqueries deep.
Mhm.
And it's not straightforward at all. Like nothing anyone would want to use.
So what you're telling me that FME is actually going to use the services rather than go directly to the database.
Correct. You have to, you don't have a choice.
Well, and we were able to actually make sense through our own SQL experience and acrobatics. We were able to deconstruct and able to go directly to database.
You can.
Yeah, it's a bit complicated, but it's not too bad. It's actually not as bad as traditional versioning, where you have to rely. Of course, you can rely on its own view, right? And the view was actually the traditional versioning's view was created very ugly, that contribute to the slowness and performance issues of Esri. I think the newer design, the branch version designing actually is cleaner and bit cryptic, but does not involve additional tables like add table and delete tables and insert tables or what have you, making it more performant just purely from the database perspective. Yeah. And so I'm a bit surprised, but certainly Esri would not like you guys go directly to its own database, and they would prefer you go through the tier at the service level. I don't understand that, but still it doesn't mean we couldn't really make sense out of it, of its own branch versioning data structure. which allow you to go directly, even to update directly without going through their services. That's still possible.
You can, as long as you understand, like there's 3 keys that are involved. You've got the archive OID, the version ID itself, and then the object IDs, because object IDs aren't unique anymore.
Right, right.
So
Yeah.
you can't, and you can't just trust that to date is null is the most current data. It would be interesting to see how you guys are interpreting it. I think I'd sent a document I wrote on how to deconstruct the archiving versioning, of like, to select out the default version versus all the other versions in the base table to see how it compares to what you guys are doing. I based it on an article that I read from Esri on the branch versioning architecture.
Mm-hmm.
And because to me, it's like I said, it's like multiple subqueries if you want to try and create some type of view based on a version to be able to accomplish it. But like I said, it shouldn't cause a lot of problems until you need to like backdoor a correction. That can get tricky, and we occasionally have to backdoor a correction into the like the centerline sequence table ends up with a duplicate or something like that. That's where it's come into play. However, I'm also working with the Roads and Highways REST API, which would allow you to be able to create bulk services to be able to load like data from an entire county and load that directly into Roads and Highways without having to backdoor it, where it would actually write to the LRS edit log so that you'd be able to use it for conflation and time slicing. So, that's worth looking at. It's clumsy and there's no built-in support for it from FME. So you've got to build all of that REST API calls yourself. And even though they call it a REST API, it's really form submissions. It's not like just JSON.
It's still kind of bulk. It still allow you to do bulk. Yeah, I feel like the direct database access will give you, the investment over there will make the batch process faster. So you're bypassing the service layer potentially, and there's more flexibility potentially. But again, this is the area FME could help us to speed things up and what have you. And I will be going to, I don't know how many of you are going to the FME UC next month. And I will be there, and I would love to see. I know David Ronio will be there, I'm pretty sure, and he has a couple presentations to make. And anyone going over there, and give me a shout, and love to catch up with you guys and over there.
Cool.
So, yeah, we're coming up on 1 hour. I guess it's time to wrap things up. Tom, I hope I spelled your email address properly here on my slide. I didn't have it initially.
Yeah, it's actually I have an old account and that corresponds to my old account. So I think it's thomas.acree at .ohio.gov. Yeah.
Okay, let's see if I can update that real quickly. There we go. All right, well, thank you everybody for joining us. Our next meeting is tentatively scheduled for September 21st, and we are looking for new presenters. Jenny said that she has some potentials, but if you guys also know of anybody who would potentially like to present, please let us know, because we'd love to add them to our list. And thank you all for coming. And thank you, Erin, Ethan, and Tom, very much for your presentation. It was fantastic.
Thank you.
Sure.
Well done. Thank you again.
Yeah.
Bye-bye.
Yep. See ya.
Bye-bye.
Bye.